Hey everyone, in today's video we'll see about NumPy, which is the foundation of efficient numerical computation in Python. Here in the sidebar, you'll see a clean navigation menu. Let's click on Overview. I just created a dashboard to explain some of the key concepts in NumPy. It's a powerful Python library used for numerical computation, especially useful for handling large data sets and performing mathematical operations very efficiently. You can also see some key features listed here like n-dimensional arrays, fast mathematical operations, broadcasting support, linear algebra functions, and random number generation. Next, we jump to creating arrays. This is where we show the various ways you can create arrays in NumPy. You will see code snippets using NP, and here comes the cool parts. We have added interactive sliders that let users pick the number of rows and columns, generate their own zero arrays in real time. Now, onto the indexing and slicing. A must-know concept when working with NumPy arrays. We showcase a one-dimension array from 0 to 9 using NP arrange of 10 and demonstrate. Basic slicing, reversing arrays, extracting a specific slice, then we go a step further and work with 2D arrays, accessing specific elements like matrix 1, 2. The goal here is to help users get comfortable navigating multidimensional data. Under array operations, we showcase powerful element-wise and vectorized operations. This makes user realize that with NumPy, they can write less code and get more performance. It's what makes NumPy such a good game changer in Python. One of NumPy's most mind-blowing features is broadcasting. We take two arrays with different shapes and still add them together seamlessly. Using broadcasting, this operation just works. The system expands one array to match the other behind the scenes. This section is critical for learners who want to write smarter, more efficient code. Okay, let's go practical with real world examples. First, we show how to normalize a data set column, a common task in data preprocessing. Then we simulate 1000 dice rolls under NumPy's random capabilities, calculate the mean, and display the distribution using a bar chart. Finally, we have the NumPy playground, a mini IDE right inside Streamlit. This is where users can write their own NumPy code. We have included a default example where two arrays are added. You can define any logic you want, and as long as you define a variable named result, the dashboard will output the results. And if you're teaching, learning, or just love interactive tools, this dashboard is for you. You can run it locally with Streamlit, customize it. If you found this useful, don't forget to like this video. That's all for today. Thanks for watching.